Hello everyone, welcome to Networkers Home. Welcome to our sixth episode in the scenario based questions. So today we have the first question. The question is telling that you are a network administrator managing a network that uses OSPF, that is Open Shortest Path First, as its interior gateway routing protocol, as it IGP protocol. Now it says that your network topology includes a central area that is called as a area 0, even we can call it as a backbone area, and it has been connected to other non-backbone areas through ABR, that is area border routers. So what it says that lately what happens now, lately a users in a specific branch office connected to a router in area 1 are reporting intermittent connectivity issues to the resources located in other areas of the network. So we can consider that, let's say that we are having certain routers, like router 1 we have router 1, then router 2, router 3, router 4, and router 5. So router 1 and 3 and even 2 is having certain interfaces in the area 0, whereas router 4 and router 5 belong to different area that is called as a area 1. Now as this router 2 is having certain connectivity in area 0 and even in the area 1, that's why we can call here router 2 as a ABR router. So here who is the ABR router? Router 2 is going to be my ABR router, that is area border router. Now what it says that what happens that some of the routers belonging to any area 1, let's say, is unable to communicate with any other routers belonging to, let's say, area 0. So what can be the reason of this connectivity issues? So we will be discussing this part based on that OSPF, regarding OSPF, that what all the things we can get, what all the regions do we have in the OSPF where my devices in one area is unable to reach devices in another area. That we have to verify, and this we have to troubleshoot. So first, like if this is a scenario, it means that we will be having OSPF running on all the routers. So first we need to run the OSPF on all the routers. So this is, we are on the router 1. Do show IP interface brief. So if we check here, do show IP interface brief, we have configured the IP on the router 1. We are on the router 1. So it is telling you 10.1 we have, on the loopback we have 1.1, and on the loopback 2 we have 2.2.2. Now we'll come to this router second. Now we'll check do show IP interface brief. So here we have on the router 2, we have configured the IP on the interface 0/0, that is 10.2, on interface 0/1, that is 25.2, on interface 0/2, that is 24.42. This all three IP we have configured on the router 2. And come to router 3, do show IP interface brief. Here we have configured only one IP, that is on the interface 0/0. Then we have on router 4, do show IP interface brief. So on the router 4 we have one IP that is configured on the interface 0/0, and the IP is 192.168.24.4. Then on the router 5, do show IP interface brief. So we have the IP that is 25.5 and it is configured on the interface 0/0. Now first come to router 1. Now if we give here router OSPF and if process ID 1, and then we will give a network 192.168.10.0 and 0.0.0.255, and area is going to be 0. Same network 1.1.1.0, 0.0.0.255, and area is going to be 0. Then one more network 2.2.2.0 and 0.0.0.255, and area is going to be 0. This is on the first router. Come to second one. So on the router second, we will give router OSPF, process ID, let's say one only, and network 192.168.10.0, 0.0.0.255, and area is going to be 0. Same network 192.168.24.0, 0.0.0.255, and this time area 1. Then again one network 192.168.25.0 and 0.0.0.255, and area is going to be same, that is 1. So this is the ABR router where we have configured the network information regarding area 0 also, and the network information coming under area 1 also. Come to router 3. So router 3 is in area 0 only. So router OSPF 1 and network 192.168.10.0 and 0.0.0.255, and area is going to be 0. Give exit. Come to router 4. Router OSPF1 and network 192.168.24.0, 0.0.0.255, and area is going to be 1. Give exit. Next, come to router 5. Router OSPF 1 and network 192.168.25.0, 0.0.0.255, and area is going to be same, that is 1. Give exit. So in this scenario, what will happen? They all will have the neighborship, and even they will have the route information. They will exchange the route information. So we can check on the router 2 with the command do show IP route. So router 2 is getting the information regarding 1.1.1 and even regarding 2.2.2. But if you will check on the router 3, it will also receive do show IP route. It is also getting on the router 4 do show IP route. So even the router 4 is also receiving the information regarding 1.1.1 and even 2.2.2, and how it is receiving this information with the help of inter-area communications. On the router 5, if we check do show IP route. So here we have the information regarding same 1.1.1 and even regarding 2.2.2, and this two information is coming under inter-area because this two information is in area 0 and we are checking on the router 5, and router 5 is in area 1. That's why we are getting here inter-area. Now there can be multiple scenario where we will be not receiving the route information from the area 0 or from like router, that is router present under this area 1 is not able to communicate or not able to receive any route information from the router belonging to area 0. That scenarios can be based on the, we can say, criteria to form the neighborship in the OSPF. So in this we have multiple different criteria. Among that we have is the router ID must be unique between the two devices. That if this router ID is not unique, then what will happen? Neighborship will not be found. So we know that we have different ways of having this router IDs on the routers. So it can be manual, it can be the highest IP on the loopback interfaces, or it can be on the highest IP on the loopback physical interfaces can be also the router IDs. So as of now, we have not given the router IDs of the router. So it means it is going to take it from the loopback interfaces or it is going to take it from the physical interfaces. Then it says that the interface must share a common subnet. It means that if we have two routers directly connected, they should have the common subnetworks. It should not that they should like they are not belonging to a common subnet. Then they will not form the neighborship. Apart from that, even the interface maximum transmission unit, that is MTU, must match because OSPF protocol does not support this fragmentation. So even if M2 is not matching, then what will happen? Neighborship will not be formed. Then area ID must be matched for that segments. But what happened that as we are having certain routers in the area 0 and certain routers in the area 1, so they will exchange the route information because it is said that if you have to enable the communications between different area, then routers should be connected to at least a backbone area. So here what is happening, that my router 4 and router 5 is connected to ABR routers, that is router 2, and they all belong to area 0. The ABR is going to have certain interfaces in area 0. That's why they can have the communications. Even it says that the need for a DR must match for that segments. Like this statement means that network types should be same to form the neighborship. Okay. Now, hello OSPF hello and dead timer must match for that segments. Hello timers and dead timers should also match. Then if we have done any authentications, so for that authentication should also match to form the neighborship. And the last one is that area type flags that must be identical. Like we have, if we have configured stub, then we need to configure the stub on all the internal routers so that they can exchange the route informations. So some of the network types or some of the conditions, like neighborship conditions in the OSPF, already we have discussed in the last video. So like today, let us discuss about this one, the part that the need for a DR must match for that segment. And then we will come to the next part, that is stub part. So if we come on the router 2, and if we check here, do show IP route, so it is getting the information. And if we check do show IP OSPF neighbor, so it will give you the information regarding all the neighboring routers, neighboring information. Now what if I on the router, if on the interface on the router 2 on the interface 0/0, I change the network type. So first we will see how to check that network type. So if we come to interface 0/0, or we give a command do show IP OSPF interface. So if we will give this command IP OSPF interface, so it will show you that the network types of the OSPF. So one is what? This is regarding network type is broadcast, and this is regarding what? 25.2. So it means my network type is what? Broadcast. Now if I change the network type, for example, if I change interface 0/0 and I give IP OSPF network, and if I give a question mark, and if I change it to, let's say, point to multipoint, point to multipoint, give accept. So as soon as I change the network types, what happened? Neighborship is down. Okay, what it says, interface is down or interface is detached. So there can be multiple reasons where my routers sitting in area 1 is unable to receive the information from the router sitting in area 0. So in that we can have this steps also where the network type is not same. Because if you will check on the router 1, do show, see it is telling you full to down. Now do show interface, let's say 0/0 only, or do show IP OSPF or interface first. So it is telling you what? Broadcast type. But when we check on the router 2, as we have changed that, so do show IP OSPF interface. Point to multipoint. Okay. Now, as it is point to multipoint, then if we again change interface G0/0 IP OSPF network as a broadcast, give exit. So the neighborship has been formed and it came to routing to full state. So now if we check do show IP OSPF and interface, so it is having in what state? The network type is what? Broadcast, and it is in the full state. So this is one of the scenario. Now let's say what happened, that generally we know that always we will be not using only OSPF. For example, let's say on the router 1, as of now, we have one IP 1.1.1 and one more IP we have configured on the loopback of the router 1 only, that is 2.2.2/24. And this two IP we have not like now we have advertised using OSPF. Now let us change that. What if we change it and we redistribute that network? So in that scenario, what will happen? My AVR will receive that information, but this time not as an internal information, but as a external information, external route information. And this will be have this is the scenario that we are going to have in the real, because there it will be like redistributions. So if we check, because we can use multiple different protocols as well. So if we give here router and OSPF 1, and if we remove that, no network 1.1.1.0 and 0.0.0.255 and area is 0, and even we remove no network 2.2.2.0 and 0.0.0.255 and area is 0, and what we do, we redistribute the connected information. Now if we have redistributed it, and now if you will check on the router 2, what all the information it is receiving, that is AVR. So do show IP route regarding 1.1.1.0. And what is this? 2.2.2.0. And what it is? External. Because we have not advertised using OSPF, but we have redistributed it. Now, if we check it on the router 4, that is also in my ABR, sorry, in area 1. So do show IP route. So earlier it was getting this information, inter area. Now it is getting external information regarding 1.1.0 and even regarding 2.2.0. If we check on the router 5, do show IP route. Same here also, it is getting it externally. And if we check on the router 3, that is in area 0 only. So do show IP route. So even it will receive as a external, because we have redistributed these two IPs like 1.1 and even 2.2. Now, what will happen if we use stub here? So what is that stub? So it says that OSPF stub area is a special type of OSPF area that is designed to reduce the size of the routing table and even to limit the number of LSAs, that is linked state advertisement, inside this area. So OSPF stub area prohibits what? Type 5 LSAs, that is external route, and even type 4, that is AS-based summaries, from entering the area at the AVR routers. So when we will be getting here type 5 LSAs, when we have any external route information. So as of now, what we did, that we have two external route information. If we check on the router 2, do show IP OSPF database. Check it on the router 3, router 4 first. Do show IP OSPF database. So here we are getting some ASB link state information on the router 2. If we check, do show IP OSPF database. Here also check on the router 1, do show IP OSPF database. So here we have what? Type 5. So like this type 5 information is present because we have redistributed some of the IPs on network we have. Now, if on the router 2, let's say that is on the AVR router, if I configure here router as OSPF 1 and area as 1 and a stub, so it came to filter down. And even if you will check on the router 4, do show We can check to show IP route. It will take time and it will remove this information. Yes, it also kept it down. Yes. Now router 4 is not having the information regarding 1.1.0 and neither it is having information regarding 2.2.0. Even on the router 5 we can check do show IP route. It is also not having. So what we did, like we tried to implement a stub on the router 2, that is ABR router, so that I can remove this type 5 LSAs. And whatever the route I should get on the router 4, it should be like a default route. So what happens that whenever you will implement this stub, so whatever the external route information we are getting now, so that route information will be delivered to this other routers in this area as a default. Okay. Now, as of now, on the router 4 and on the router 5, we are unable to receive this information. The reason is because we have not enabled this stub or we have not configured this stub on the router 4, on the router 5. And only we have configured it on the ABR routers. So even we need to form this ABR or stub, we need to configure this stub on the router 4 and even on the router 5. So how we will configure this? Router OSPF 1 and area 1 as stub to exit. Same we have to do it on the router 5 also. So router OSPF 1 and area 1 as stub to exit. Now if we check on the router 4, so it formed the neighborship. Now when you will check the routing table, do show IP route. So see here we are getting the information 10.0.0/0. And if we check do show IP OSPF database, so here also we have this one. And on the router 1, do show IP OSPF database. So here we will have all these things, but on the router 4 and 5 we are not receiving that. We will receive that route information, but as a default route, not as an exact route information. That is 0.0.0/. So this is a use of the stub. Okay, so there can be multiple various reasons where my devices located in one area is unable to communicate with the devices located in another area. Apart from interface parameters also, there could be multiple scenarios in the OSPF only. Based on that, it is not happening. So today we discussed the first part regarding network types, and the second part we discussed is regarding the stub. Thank you very much.